Alright again, YouTube learners, welcome back. We're gonna now discuss about chemical equations. Now, instead of word equations, we can give a little bit more information to your reader if you give them a chemical equation. Now, I'm not gonna start blowing you up with really heavy stuff because you gotta learn in this process. But in a nutshell, a chemical equation uses symbols and chemical formulas. So if you still got questions about writing formulas and stuff like that, you got to go back to the videos, the previous videos, and learn how to write formulas. And you got to get worksheets that have answers online, and you just got to do it. You got to learn how to write your chemical formulas, because ultimately you will have to learn how to predict what kind of products are made, and you have to learn how to write the right formulas so you can balance the equation. Okay, a chemical equation basically gives us some information, all right? It's a symbol. Instead of writing long words like magnesium and oxygen, now we can see that the atom or the makeup of the chemical. For example, this is an element of magnesium, so it's just Mg, and that oxygen that we reacted the magnesium with is a diatomic molecule with two oxygen atoms making up that molecule. And then it will make a magnesium oxide, which has a ratio of one magnesium bonded with one oxygen. Wonderful. We can get all this information out from a chemical equation. But a chemical equation needs to be balanced. And why is that? Well, according to the laws of conservation of mass or matter, nothing is created nor destroyed. And so when you look at a chemical equation, the amount of magnesium you put into the reaction has to be the same amount that comes out. And so that's oxygen that goes in and the oxygen that goes out. So here I have one atom of magnesium, and at the product side I have one atom of magnesium. Good. Or one ion of magnesium. All right, so that's good. Here I have two atoms of oxygen to make up that molecule, but in the magnesium oxide I only have one oxygen. So it's not balanced. So we need to balance the equation. Now, there are many ways to balance an equation, but here are my rules. Whoops. Rules to balance chemical equations. Follow these 4 simple steps, and you should always come up with a balanced equation no matter what is thrown at you. So here we go. First, you balance the cations or metals in that equation. Secondly, you balance the nonmetals or the polyatomic ions in the equation except for the hydrogens and the oxygens. Why? Because hydrogens and oxygens tend to be everywhere all the time. You know, like buggers and stuff. All right? And then you will balance the hydrogens. After balancing the hydrogens, you will balance the oxygens. And then, of course, you've got to chickity check your work. Chickity check it out before you wreck it out. You've got to chickity check it out before you wreck it out. Okay, so let's just get back to it. And now I'm going to do a slow step-by-step in terms of balancing equations. And awesome. Well, once you finish writing down your formula, you do not want to change it. So you better make sure that your formula is correct. So what I do is I write a box over the formulas, and I do not write anything inside that box, but I leave a little space here on the left side of the formula, and this is where I'm going to put in my numbers, my coefficients. So here I go. I'm not going to put anything, change anything about the formula because I know it's right. Okay, and here we go. Okay, so do not write anything in these formulas. Fantastic. And now, following the rules, balance the metals first. So here I have magnesium, and on the other side, on the right side of the equation, I have magnesium. So one magnesium here, one magnesium here, it's balanced. Moving on to step number 2. Are there any anions or polyatomic ions here? Nope. Step number 3, balance the hydrogens. Are there any hydrogens in here? Nope. Okay, moving on. Step number 4, balance the oxygens. Here I have 2 oxygens and here I have 1. So because there's 2 over here, I cannot subtract, all right? I cannot subtract the number of oxygens. I can only add to this side. So to make 1 to 2, I need to multiply this by 2. So instead of writing 2 here, no, that's not correct. I can't change anything in the box. I can only change the stuff up here. So the only thing I can do is to write 2 here. And that gives me 2 oxygens on the right side and 2 oxygens on the left side. But when I put the 2 here, I changed something. I changed the number of magnesium. Go back to step 1. I need to change that cation of metal here. So I have 2 magnesium here and 1 magnesium here. So it needs to be balanced. Again, I can't take numbers out from this, because if I do, I'm going back to the same problem I had earlier on. So I need to add numbers onto it. So 1 times how many will equals to 2? 1 times 2. So here I have 2 magnesium. Finally, you've got to check your work. So I have 2 magnesium atoms here, 2 magnesium ions here, 2 oxygens here, and 2 oxygens here. This is a balanced equation. Next example. I have potassium rock reacting with water to give potassium hydroxide and hydrogen. Balance the equation. Boom. Write a box around it so that you don't manipulate anything that's inside the box. You don't change the formula just because your things will not balance. You gotta just try harder and look at it. Okay, balance the metals first. 1 potassium here on the left side, the reactant side, 1 potassium here on the right side, the product side. Okay, good. Let's move on. Any other anions or polyatomic ions or whatever, or non-metals? No, because we only got hydrogen and oxygen. So move on to step 3. Balance the hydrogen. Here I have 2 hydrogen, here I have 1, and here I have 2. That's kind of odd. So there's 3 hydrogens here and 2 over here. So that gives me a very weird ratio. What am I going to do? Well, let's see. I can put maybe 3 here, so I get 6, perhaps. Okay, let's just try that, right? Because I'm going to trying to get 3 because here's 2 here, and so now I have 6 hydrogens here, and then let's say 3 over here. So maybe I would like to get 6. So what can I do? Maybe I can do this, perhaps, so that I get 3, right? 3 hydrogens here and 2 hydrogens here. That's 5. So that does not work out for me neither. So let's try that another number. Let's try with 2. Okay, 2. So I got 2 hydrogens here times 2. That's 4. 2 here, and I got 2 here. So okay, I got 1 here. So maybe I'll make another 1. So to make that 2. Okay, and then boom. All right. I've got 2 hydrogens here and 2 hydrogens here. That's 4. 2 hydrogens here. 2 times 2. That's 4 as well. So okay, that's good. But guess what? I changed the number of K's, didn't I? Because I changed the number of H's here. I changed the number of K's. So because I changed the number of potassium, I got to go back to step 1 and then change that as well. So I have 2 potassiums on my right side and 1 on my left side. I need to change that. All right. Now let's go back to step 3 and see that hydrogens are still balanced. We did not manipulate anything else. Okay, last step to balance the oxygens. Here I have 2 oxygens, right? Because 1 times 2 is 2. Here I have 1 times 2 is 2. Well, what do you know? It's balanced. Whew. That was a bit of a doozy, wasn't it? Now, another example. Here I got methane reacting with oxygen and carbon dioxide to get carbon dioxide and water. Okay? let's balance this. There are no metals here, so I'm going to skip step 1. Alright, the nonmetals, or anions. Here we go, I got a nonmetal here, carbon, so I'm going to balance that. There's one carbon here and one carbon here, balance, easy. Let's move on to hydrogens. Okay, there's 4 hydrogens here, there's 2 over here, so let's add 2 times 2 is 4. So now I got 4 hydrogens here and 4 hydrogens there. What about oxygens now? I have 2 oxygens here, 1, 2 here, 3, 4 over here. Okay, because 1 times 2 is 2, plus another 2 here, that's 4. So here I'm only behind by 2 extra oxygens, so I'm going to add 2 here, and that's balance. Whoopie dude, that was easy. Let's change this up a little bit. Let's say that instead of simple methane, let's say it's ethane, for example. So now my numbers will need to change. Okay, again, to balance this one, I got to draw the box around it. And let's start with carbon again. 2 carbons here, 1 carbon here, so I need to change that. Write 2 here. Okay, let's balance the hydrogens now. There's 6 over here, there's 2 over here, so I gotta multiply this by 3. For the oxygens, I have 2 oxygens here. And then over here is 2 times 2 is 4 oxygens. And then I have 3 oxygens here. Now, add up the product side, it gives me 7 oxygen atoms in total. That's kind of weird. How am I going to get 7 to balance with 2? Well, I could write this. 7 divided by this 2 here, right? If this was a 2, I divide this by 2. If this was a 3, I divide this by 3. So this is what I did. This is a little trick I'm teaching you guys. Alright, so there is 2. But we can't have a fraction of a molecule, right? So what we do is we will do a simple mathematical trick. We will multiply the entire equation by 2. And so what we end up with is 2 times 1 is 2. 2 times 7 and halves is a 7. 2 times 2 is a 4. And 2 times 3 is a 6. Let's double check our work. Checkity check. How many carbons? 4. 4 carbons here. How many hydrogens here? 12. How many hydrogens here? 12. How many oxygens we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 6 oxygens here. That will be 14. And then 7 times 2 is 14 oxygens here and 14 oxygens here. So the equation is balanced. Awesome.